My name is Neerja Arora and I'm working as an assistant professor in CSC department at Ajay Kumar Garg Engineering College, Ghaziabad. Okay, so today I'm going to discuss a topic that is switching techniques, which comes under the subject computer networks, having code KCS 603. So, what is a network? Basically, a computer network is a collection of autonomous nodes which are interlinked with each other, with one another through some transmission media, either wired media or wireless media, so that the devices or nodes can communicate with each other and share the resources with one another. So, the topology of a network or a computer network basically refers to a way in which a network is laid out physically. So, it is a geometrical representation of the relationship of all the links and the linking devices, which are usually known as nodes, to one another. That is, suppose we are given a 5 number of nodes or a 100 number of nodes, then how these nodes are connected with one another so that they can communicate with each other. So that representation or geographical representation of the links or how these devices are connected with each other is known as topology. So basically we are having 4 basic topologies. One is mesh topology, which is a point-to-point connection which makes the stations connected with each other through a point-to-point. That is, 2 stations are directly connected with one another. Suppose if a station 1 has to send data to station 2, then it can send its data directly to station 2. Similarly, this is a star topology. It also provides a point-to-point connection between a station and a hub. And rest 2 topologies, bus topology and ring topology, these are the multi-point topologies, which provides in which the bandwidth of the cable or capacity of the resource is shared by the multiple devices simultaneously. So, if we have to design a large network having large number of devices or nodes, and then the mesh topology and star topology are basically impractical and wasteful to provide one-to-one communication possible, because the number and length of the links required in case of mesh and star topologies for designing the large networks which are having multiple devices, huge number of devices, it may require too much infrastructure, and majority of those links would be idle most of the time. And this requirement of the large infrastructure makes the network very expensive. So these 2 topologies are not possible for designing the large networks. Similarly, other topologies which employs multi-point connections such as bus topology are also ruled out, because there is a constraint in bus topology that we can connect limited devices, and there is also a constraint between on the distances between these 2 devices. So if the distance between the devices and the total number of devices increases in case of bus topology, then it may make the communication inefficient, or it may degrade the quality of communication. So the better solution to design large networks is switching. So what is a switched network? Basically, a switched network consists of series of interlinked nodes which are known as switches. Basically, switches are the sophisticated devices which are capable of creating temporary connections between the 2 or more devices which are linked to a switch. As you can see in this particular diagram, we are having A, B, C, D, E, and these are the N devices which are linked to one another through switches. We are having 5 switches here. So basically, switches are used to make the temporary connection between the N devices. Suppose if a device A has to communicate with the device F, then the intermediate switches basically makes a temporary path or temporary connection between these 2 devices so that they can communicate with one another. So in a switch network, some of the nodes or switches are connected directly to the end devices, as you can see in this diagram. But it is not mandatory that each switch must be connected with end devices. For example, we can also have one switch number 6 in between switch 2 and switch 5. And this particular switch is not connected to any end devices. It is connected with only switch 2 and switch 5. Okay. So that switch is used only for the routing or connection between the switch 2 and switch 5. It is not mandatory that it is connected to any end system. Basically, we are having three types of switching or switching methods through which we can create a large networks. One is circuit switching, second is packet switching, and third one is message switching. And packet switching is further classified into two methods, datagram switching and virtual circuit switching. So let's start with circuit switching network. Basically, a circuit switching method takes place at the physical layer of the OSI model. And a circuit switch network is made up of a set of switches or a number of switches which are connected by the physical links, in which each link is divided into n number of channels by using multiplexing method, either frequency division multiplexing or time division multiplexing. So basically, this is a circuit switch network in which we are having four switches: switch 1, switch 2, switch 3 and switch 4. All these switches are interlinked with one another through some link, and the link between two switches is divided into n number of channels by using multiplexing technique. If we have used frequency division multiplexing technique, then the link is divided into n number of channels on the basis of frequency bands. Okay, so suppose we have a one channel for some frequency band, and we can also have another channel with some another frequency band. And if we have used time division multiplexing, then in that case the link is divided into n number of channels on the basis of their time slots. Okay, it means that link is shared by devices or multiple devices on the basis of their allocated time slots. So a connection between the two stations is a dedicated path made up of one or more links, and however each connection uses only one dedicated channel on each link. For example, if a device A has to communicate with device M, then first a dedicated path or a dedicated channels are reserved or allocated for these two devices. It means अगर A को कोई डेटा अपना सेंड करना है M को and M को अगर communicate करना है A से, then all the data will be transferred through that particular channel only, and that combination of channel is known as path. So in a circuit switch network, a circuit is created or a path is created, dedicated path is created between a sender and a receiver, and all the communication will be done through that particular path. So the actual communication in a circuit switch network requires three phases. First is a connection setup phase, second is a data transfer phase, and third is a connection tear down phase after the completion of the data transfer. So if any system want to communicate with any another system over the network, then the sender has to first make a connection request. Okay, it has to generate a request, and that request must be accepted by all the switches and the receiver as well as. And this step is known as a connection setup phase. And if the connection request generated by the sender is accepted by the receiver or all the other switches, then a circuit or channel is reserved on each link, and the combination of circuits or channels defines the dedicated path between a sender and the receiver. And if the dedicated path made up of connected circuits or channel is established, then only data transfer will take place. And if all the data has been transferred, then that circuit will be teared down. Okay, so before the data transfer, first the connection is established between a sender and the receiver, And if the connection is established, then all the data will be transferred, and after completion of the data transfer phase, the connection will be terminated. So these are the few key points of circuit switching. First, before starting the communications, the station must make a reservation for the resources to be used during the communication, and these resources would be channels, or if we have used frequency division multiplex, in that case the bandwidth will be reserved, and if we have used the time division multiplexing, then the time slots will be allocated. And other resources may be switch buffer, switch processing time, and switch input and output ports, which will be used for sending the data or receiving the data from the devices. And these resources must remain dedicated during the entire duration of the data transfer until the tear down phase. And in circuit switching, the data transferred between the two stations are not packetized. That means the data are the continuous flow sent by the source station and received by the destination station, although there may be a periods of silence. And fourth point is that there is no addressing system involved during the data transfer. The switches route the data based on their occupied band or fixed time slot. So these are the advantages of circuit switching. So here a dedicated link is established between the two devices, which provides a guaranteed data transmission. Okay. And once the connection is established between the sender and the receiver, then that data can be transmitted without any delay because they are directly connected. So no waiting time will be held at each switch. And last, a dedicated continuous data transmission path is established between a sender and the receiver. So this switching method is suitable for long continuous data transmission. But circuit switching has also few disadvantages. One main disadvantage of this switching method is that once a dedicated path is established, then that path becomes reserved and other devices cannot use that path. Another disadvantage is that this method does not properly utilize the system resources. Our resources are allocated for the entire duration, so they will not be available to other connections or for the other devices. And a dedicated continuous data transmission channel requires more bandwidth. So in case of circuit switching, more resources and more bandwidth will be utilized. So before actual data transmission, our dedicated path has to be established, and it takes a long time to establish a path. And circuit switching is also more expensive than as compared to other techniques. So these are the few disadvantages of circuit switching. Okay. Another switching method is message switching. With message switching, there is no need to establish a dedicated path between the two stations as in case of circuit switching. Here, when a station has to send a message, then the destination address is appended to the message at the end, and that message is then transmitted through the network in its entirety from one node to another node. And each node receives the entire message, data plus address, and it stores that entire message over the disk, and then it transmits that message to the next intermediate connected node. So this type of network is also known as store and forward network. So this is an example of layout of message switching, in which we are having 1, 2, 3, 4 number of end systems. So if device A has to send the data to device E, then first the device A will generate the message, append the address of the destination to that message. Then that message will be transmitted to next intermediate connected node, which is basically that is known as a message switching node, which is typically a general purpose computer system. So when a message M1 is reached at this particular switching node or a device, then it will be temporarily stored at its hard disk. Okay, so after storing, the system, that the switching node will first find out the next node to कि कहाँ पे उस डेटा को आपको फॉरवर्ड करना है. Then after finding that particular node, next node, it will forward that message to the another connected node, which will takes the message to the up to the destination. So here the device needs sufficient secondary storage capacity to store the incoming messages, which could be long. So this is a disadvantage of message switching technique, that it requires huge amount of memory space to store the incoming messages. Also, a time delay may be introduced using this type of scheme because due to store and forward time, plus the time required to find the next node in the transmission path. So that's why message switching is not efficient as compared to another switching methods. But it has few advantages. First, the channel efficiency can be greater as compared to a circuit switch system because more devices are sharing the channel. Second advantage is that traffic congestion can be reduced because messages may be temporarily stored in the route, and message priorities can be also established due to store and forward technique. Last, message broadcasting can be achieved with the use of broadcast address appended in the message. These are the disadvantages of message switching. It is not compatible with interactive applications. Plus, the store and forward devices are means the switching devices are expensive because they must have large disk space to hold potentially the long messages. Third is packet switch network. So in a packet switch network, the message needs to be divided into packets of fixed size or a variable size, and the size of packet is determined by the network and the governing protocol. In this switching method, there is no resource allocation for a packet, that is, no reserved bandwidth on the link, and there is no scheduled processing time for each packet as in circuit switching method. Here, the resources are allocated on demand. The allocation is done on a first come and first serve basis. As with other systems in our daily life, this lack of reservation may also create a delay. So packet switching is further divided into datagram switching and the virtual circuit switching. So in datagram switching, basically it is normally performed at the network layer of the OSI model. So in a datagram network, each packet is treated independently of all other packets. Even if a packet is a part of a multi-packet transmission, the network treats it as though it existing alone. It means each packet is considered as an independent packet. And in this approach, the packets are referred to as datagrams. That's why it is known as datagram switching method. And datagram networks are sometimes also referred to as a connectionless network because there is no predefined allocation of the connections or channels. No resources are reserved before data transfer phase. So when a switch receives a packet, no matter what is the source or destination, the packet must wait if there are other packets being processed, as there is a lack of reservation. And the switches in a datagram network are traditionally referred to as routers. So this is an example of packets datagram switching method, in which we are having 4 devices A, B, C and X. Suppose the device A has to send a message to device X. Then first the device A first breaks the message into number of packets. So here in this case 4 packets has been created, and after creating a packets or a datagrams, the sequence number is set to each packet. So here this packet is given a number 1, number 2, number 3 and number 4. Then if a device A has to send these packets to device X, then these packets will go to the directly connected switch of to the A. So when these packets come to this particular switch, then it is not mandatory that all the packets will go through the same path. So here the packet 3 and packet 1 are transferred through this path, and packet 4 has taken this path, and packet 2 has taken this particular path or route. So in case of datagram switching networks, it is not mandatory that there is no pre-allocation or there is no dedicated path through which all packets have been transferred. So it is depending upon the switch और पैकेट की कौन से पाथ से वो आपके पैकेट्स ट्रांसफर होंगे एट अप टू द डेस्टिनेशन. सो there are no setup or tear down phase in case of datagram networks. The packets each with the same destination address do not follow the same route as I have already discussed, and so they may arrive out of sequence at the destination end. So that's why reordering is required at the destination point based upon the sequence number of the packets. And it is possible for a packet to be destroyed if one of the nodes or switching station on its way is crashed momentarily, and thus all its queued packet may be lost. So in datagram networks, we have to use the routing table. Means all the switches or routers have to maintain a routing table on the basis of the destination address. So here, if a packet comes at this particular switch, which is having a destination address 1232, then that switch will forward that packet from its output port number 1. And if a packet comes with the destination address 4150, then switch will forward that packet to the destination through its output port 2. Okay, so this is how the routing or forwarding of the packet will be performed at the switch or routers. And these tables are dynamic and they are updated periodically, and the destination address and the corresponding forwarding output ports are recorded in these routing tables. So next is virtual circuit switching. So virtual circuit switching, basically it is a combination of circuit switching and the datagram network. It has the characteristics of the both three methods. So as in circuit switch network, there are setup and tear down phase in addition to the data transfer phase. And also as in datagram network, data are packetized and each packet carries an address of the next immediate connected switch, not end-to-end destination address. Also, the resources can be allocated during the setup phase as in case of circuit switch network, or on demand as in datagram network. And fourth point is that as in a circuit switch network, all packets follow the same path which are established during the connection. Also, a virtual switch network is normally implemented in the data link layer. So, in case of virtual circuit networks, two types of addressing are involved. One is global addressing and second is the local addressing. Global addressing is used to identify the destination node and which is unique globally. And another local address which is also known as VCI, virtual circuit identifier number, and this address is basically used for data transfer to the for sending the data or sending the message to directly next connected node. So it is used locally, that's why it is known as local addressing. So basically virtual circuit identifier, it is a small number that has only switch scope and it is used by the frame between the two switches. And when a frames arrive at a switch with particular VCI number, then it will leave that switch with different VCI number. As you can see here, the data comes with VCI number 14, but when it exits from the switch, the VCI number has been changed to 77. So in this also we are having three phases. First, the connection is established between a sender and the destination on the basis of global address. Then after connection establishment, the data transfer will be taken place, and once the data transfer has been completed, the connection will be terminated. So these are the switches and tables used in a VCN networks. So when a data comes with a VCI number 14, then the switch has the routing table. So switch first check the entry in the routing table. if a packet comes with the VCI number 14, then and it comes from the input port number 1, then the switch will forward that packet from its port number 3 and it will update its VCI number to 22. Similarly, for the next data packet. So this is the concept of VCI or virtual circuit network and packet switching. Thank you.